Hello everyone, welcome to Geeks for Geeks. In this video, we will learn how to count rotations in sorted and rotated linked list. Let's see the problem statement first. The problem statement says, given a linked list of n nodes which is first sorted then rotated by k elements, we have to find the value of k. Note that in this problem, linked list is rotated at least by one time, means value of k is always greater than or equal to 1. Let's see some examples to demonstrate the above problem. In the first example, we have given a linked list 15, 18, 5, 8, 11, 12. If we carefully observe the given linked list, the first value in the sorted linked list, if not rotated, will be 5. Since 5 is 2 away from its position, that means number of times linked list is rotated is 2. So output will be k equal to 2. In the second example, we have given a linked list 1, 2, 3, 4, 5, 6. Here the linked list is already sorted, so many of you may comment that output should be 0. But here output is k equal to 6. Let's understand this. It is because our problem statement says value of k will always be greater than or equal to 1. So in order to bring the sorted linked list back into the same orientation after the rotations, number of rotations required is number of nodes present in the linked list. Since number of nodes in this example is 6, number of times linked list is rotated is 6. So output is 6. Now let's see the algorithm to solve the given problem. We traverse the given linked list. In each iteration, check whether current node value is greater than value of next node. In other words, since the list is already sorted and only rotated, instead of comparing current node and next node value, we can check whether the current node value is greater than the head node of the linked list or not. If value of current node is greater than head node value, increment the value of k by 1 and continue traversing the linked list. Note that k is initialized with 0. Else, if current node value is less than head node of the linked list, stop traversing the linked list and return the current value of k. Now, let's see the C implementation of above algorithm. The return type of this function is int, since it will return number of rotations in linked list. The function takes only one argument, the head node of the linked list. Inside this function, we declare a variable count and initialize it with 0. This variable keeps count of number of rotations in given singly linked list. We also declare a variable min, which we initialize with the head node value of the linked list. While traversing the linked list, in each iteration, we check if value of min is greater than current node value or not. If value of min is greater than current node value, then we break the loop and return the value of count. Else, if value of min is less than or equal to current node value, we increment the value of count by 1 and update head to point to next node. Note that min value is always constant and never changes during the traversal. Finally, the value of count is returned, which is the desired output. Let's understand the algorithm using an example. We have given a linked list 15, 18, 5, 8, 11, 12. Initially, head will point to 15. We pass this head in the function count rotation. We declare a variable count and initialize it with 0. We also declare an integer variable min and assign head node value to it. So initially min will be 15. We will then start traversing the linked list. In the first iteration, value of both min and head will be 15. Since min is not greater than current head value, value of count is incremented by 1. So value of count becomes 1. In iteration 2, head pointer will move forward and will point to 18. Since value of min is less than 18, value of count will be incremented by 1. So value of count becomes 2. In next iteration, head will point to 5. Since value of node pointed by head variable is less than min, we will stop the traversal and will return the final value of count, which is 2. So finally output will be k equal to 2 for the linked list 15, 18, 5, 8, 11, 12. Time complexity of this algorithm is On, where n is the number of nodes traversed. With this, we end our tutorial. Thank you for watching. Please leave us your likes and comments.